Okay, welcome to week 6 of PLC fundamentals. This week, where the heck did my presentation go? So this week we're going to cover describe what MAC addresses are used for, describe why IP addresses are used, explain subnetting masks and how they function in. Oh, sorry, 1 second. All right, sorry about that. So we're going to go over subnet masks and how it functions on a network. Describe the function of a network gateway. We're going to go over how to ping devices over a network. It might be the most useful tool I have in my arsenal when programming. And then comparing network configurations to identify some network issues. Does anybody have any background? Hardik is here. Does anybody here have any background or experience with networking?
Yeah, we have to set up wireless routers that use SIM cards. And
Okay,
then,
microhards.
Yeah, there's those, and then we use ones they're called Cozy or E1 Cozy 131. I don't know if you ever dealt with those.
I haven't dealt with that manufacturer. Oh, my Spotify is on.
Yeah, we have to do those, and then it's really hard when you have to hardwire into their system into like a local network, and then all the IP addresses that we use get all messed up, and it can be a little complicated.
It absolutely can. You can. Am I sharing the right screen? You only see the week 6 slide.
Yeah.
Okay. Yeah. So IP networks, like any network, you can really bring down a manufacturing facility in a hurry if you. Hardik cannot hear me. Everybody else can. Okay, I can't. Yeah, okay. I don't. Everyone can hear me. I don't know what's up with your end, Hardik. I'm sorry. Yeah, if you walk into a manufacturing facility and you just plug your laptop into a switch, and your computer takes the same IP address as a piece of equipment on the network, you can bring the whole thing down if you take out the wrong. If you take out the wrong piece of equipment, if you come on and you take over a VFD that's being controlled over Ethernet, the whole thing will stop. You can fault controllers. So there are some basic tools that you can use to help prevent that. As always, your best bet is to find network drawings if those exist. Sometimes that's a laughable request, but anything. And then I'll even show you, at least with the control logics, I think I can get my phone camera running. I'll show you what you can expect to see on the front of at least a control logics processor to help you there. I'll see if I'll wait for Hardik to come back before I take off too much. All right, so some common terminology. It's client, so roughly described as a computer or device that initiates a request for data. So your computer on a network would be talking to a server. So a server would be a computer or device on a network that responds to a client by receiving or sending data. So when you connect to the internet, you're the client, you're requesting to connect to a website. If your computer pings a device or requests data from another computer, the other computer would be the server. If your computer is collecting data and can send data to a database that sits on a server or a historian. I think everybody's probably heard these two terms before. The next main one that you're going to hear is a domain. So domain is a collection of host addresses which are supervised by a domain controller. And then the domain controller is typically a server on a network. So the domain controller can do many tasks on the network. One of the main ones that you'll see is a domain controller will control access. So when you log in to your work machine, your machine will try to connect to the network and pull and confirm your identity with the domain controller. Your IT can remove your accounts and your rights from the domain controller, assuming that your network has been set up that way. Then TCP/IP is one of those acronyms from hell. So TCP is Transport Control Protocol and IP is Internet Protocol. So this is one of many protocols that allows devices to exchange data. And IP, Internet Protocol, is the most common one that Allen Bradley uses. You'll also hear it called Ethernet IP. And when they call it, Allen Bradley calls it Ethernet IP, it's their own version of an IP protocol. They do some weird encapsulation of the data, but it's essentially TCP/IP. Any questions with these? These are pretty straightforward. So what is an IP address and why are they used? So an IP address, IP addresses are used by devices to communicate over Ethernet. An IP address is a 32-bit word separated into 4 octets. You've likely seen these before. So this is an example of an IP address, 192.168.0.1. This is typically what a lot of your commercially available home routers are going to come as default set to. So you've probably seen this one where you need to connect your home router and then log into that IP address so that you can set up your Wi-Fi. So 192 is the first octet, 168 is the second, 0.1 are the last 2 octets. So your IP addresses, especially for home, are typically dynamic. A dynamic IP address means that your IP address is temporary. So that is when you plug your computer into your home router, it's going to assign your computer an address within a specific range. This is typically called DHCP. And I don't remember the acronym for that at the moment, and I apologize, and it's not on this slide. You will receive that IP address for a certain amount of time, whether it be a week or a month, however your router is configured, and then that lease will expire, and the next time you connect in, you could receive a different IP address. This is also typically done with your cell phones or even your router that connects to your internet service provider. So Rogers would be an ISP, an internet service provider. You can purchase static IP addresses. So if you were a business, some IP addresses are static, like the ones owned by Conestoga, Google, or Molson Breweries. So Conestoga has purchased a range of IP addresses that only they are allowed to use, so that they can host permanent websites on those addresses and people can access them over the internet. So when you use the Pulse Secure client and point it at, I believe it's Conestoga VPN.ca, that website that is connected to very specific IP addresses that you connect into. So if you have equipment on the internet that you need it to be in the same spot because a lot of people are always connecting into it, you would purchase and use a static IP address. So any questions on that? So what is an IP address and why are they used? So IP addresses have to be unique. So this is kind of a conceptual example that I liked and I left in here. So consider an event that runs from Friday to Sunday. Dynamic IP addresses are like the Friday, Saturday, and Sunday tickets you get entering the event. So the Friday, Saturday, and Sunday tickets have different IP addresses, so they're different tickets. So each day you would be assigned a different IP address, you would be assigned a different ticket. So the static IP addresses are like the merchant IDs, the tents. So the tents, whenever you go to a concert booth, both you're allowed in, the merchant, their stand location will be where you saw it last. So the merchants don't move because they'll have a static IP address. Well, your IP address, your location in this example, this metaphor, would be less predictable. So your IP address can change just like your ticket number could change at this event. So does that make sense? It made more sense to me when I was reading through this. So the static IP, yeah. So the static IP address and the websites are like the merchants. So they set up semi-permanent shop on the internet, hoping that you'll come around. So the server IP address there, the dynamic IP addresses that you get helps that the static IP addresses helps the network know who you are, and when you leave, those addresses will be gone. They can be assigned to somebody else once you've left as well. So this image, so this command prompt, I'll show you how to pull this up. So considering the following image, this device was assigned an IPv4 address, and you can see on October 11th, 2020, and it will be assigned a new one when that one expires on October 19th. So you can see the lease obtained and the lease expiry date. So IPv4 just means the 4-octet IP address that you'll see here highlighted. So 192.168.0.71. IPv6 is a newer standard. They came up with it when they were concerned that the world was going to run out of IP addresses. So they came up with a new standard. IPv6, it's backwards compatible to IPv4. It just has 2 extra octets at the beginning. So your IPv6 address would look something like this. It can also be read in hex. That's why you can see letters and numbers mixed in there. So an example of an IPv6 address here is 193.124.10.31.33.10, has 2 extra octets at the beginning of it. Any questions about this? So the command prompt, which we'll get to in a bit, is the easiest way to help you find network information, especially if you show up to a manufacturing facility and they already have computers running on the network and you don't know the IP addresses. If you can remember these very simple and very easy to use commands, you can normally really help yourself get on to the network. Most manufacturing facilities do not have programming laptops. So if you show up to site and you need to get on the network, the last thing you want to do again is plug in and bring down their server or bring down something. So subnet masks. So subnet mask is used to define the device's local network. So subnet masks are used in conjunction with IP addresses to define what local devices can talk to each other. So you've got a local area network. So these are your home networks, your gym, your office. This is your local area network. And then there's a wide area network. So a larger factory will have a WAN, which is broken into different subnets. So if you can think if you've got your network as a giant building, and when you break down the IP addresses, if you have what's called a flat network, you can only have 192.168.1.0. Each octet can only have 255, actually less, devices on it. And sometimes you don't want all your devices to talk to one another. You don't necessarily want your the computers in finance to be able to see your CNC machines. You don't want the artists in product development and marketing to be able to see the engineering computers per se. You don't want them to see the servers for your manufacturing. You just don't need that crosstalk between all the switches. So you can use routers, and you can, if you don't have complex routers, you can use subnetting to break down the network into different smaller segments. So the subnet mask is also a 32-bit word and broken up into different octets, just like an IP address. So an example, and the most common example, is 255.255.255.0. 99% of the time, you'll find that most networks will use this subnet mask because it's the most open. A subnet mask is a 32-bit word. Each 8 bits is called an octet. For example, 255.255.255.0. So if there's a 1 in in a location of the subnet mask, then the corresponding bit in the IP address for that part of the network needs to match. Okay, this is a little confusing. So the next slide will help explain it. But what it's talking about is ones and zeros is when you break down each one of these words. Remember how we converted decimal into binary? So when the subnet mask is broken into binary and the IP addresses are broken into binary, you'll see here that what happens when the subnet masks don't match and why things can and cannot communicate. So for this example, we have two devices, 162.61.244.24 and 162.61.244.154. Their subnet mask is 255.255.255.0. So again, 255 broken into binary is all ones. So if you take the subnet mask of 255.255.255.0 and write it out as in binary, you get all ones, all ones, all ones, and 0. So what the last slide was saying is that when you do this, you create this mask. Anytime there's a 1, when you do the same thing for the other IP addresses, that value on the corresponding bit for that octet must match. If there's a 0, we don't care. So with 255.255.255.0, then all of these bits for both of the IP addresses must match. So these devices will communicate with one another because all of these bits match, all of these bits match, and all of these bits match. And since 0, we don't care, all of these work. Because this passes that mask check, these devices can communicate with one another. We're going to go over this a few times, but does anybody have any questions? This is one of those things that when it clicks, it'll click. But I will tell you that I'm always happy when I see this as the subnet mask, because then I don't need to mess around and guess at how the network's been segmented up. So next example. So 162.61.244.24 and 162.61.244 and 145. But this time, the last octet of the subnet mask is 128. 128 written out as binary. We can see here that, well, these ones all must match. So we know that 162, 61, and 244, these match. But these last two is where we'll run into an issue. So 128 breaks the network down into, I think, 16 different segments. So we can see here that because this one doesn't match on both IP addresses, we'll know that these two devices cannot talk to one another. These 3 line up and all of these zeros line up, but because these 2 don't in the mask don't line up, these devices are on different pieces of the network. So when you take 128, you actually divide up that segment of that whole network into different segments, and 24 and 154 are on 2 different segments, so they can't communicate with one another. That makes sense? Let's do it again. So 162.61.244.2 and 162.61.244.20. Subnet mask of 240. Can these communicate? Anyone have a guess? Vincent says no. Robert says no. They cannot, because we don't care here, but these must match. But because this bit is a mismatch, they cannot. So subnet masks, it seems really complicated, and there's some math behind it for calculating network segments, which is all beyond what you need to know to get online with PLCs. If you can understand if two devices can talk to one another, then you can set up messaging between them. Beyond that, you can start to calculate, or at least figure out what, with the subnet mask, you can derive the addresses that will communicate. So I think this is the last example. So subnet mask of 240. Can these two devices talk? I'll give you guys a few seconds. And if you said yes, you are right. The first three octets match. All of the ones match, and these ones we don't care about. So we're good. Oh, and we have one. Oh, sorry, I lost count of the examples. 240. So again, 2 and 166. Can they talk? No. So yeah, the first three work. Thank you, Ardik. But that one doesn't work, and you might as well not even keep going. Any questions about subnet masks? Is there a way to tell with just the IPs? No, you really do need to know the subnet mask. When you launch your what's my IP address, your subnet mask will be there. So when you figure out what the IP address is, you should be able to see the mask. If you are on the network and you can ping them, like if you're sitting at .2 and you are .3 and you can ping 166, then yes. But if the subnet masks are set up and you don't know them and you start pinging around, you can't. If this were like 162.11 and 162.61, odds are they can't communicate unless there's routing in place, and routing's a little beyond what we're really going to cover here. We're going to touch on Ethernet gateways, but with just the IP addresses, you can guess and maybe, but there's so many things that could be without knowing the layout of the network. You couldn't guess yes. I've seen a manufacturing facility with like 10 identical like drill mandrel machines, and when you connect into each one of the drill mandrel machines, the IP addresses are identical. So the machines couldn't exist on the external network without special routing, because anytime somebody plugged the machine into the main, two machines into the main network, they'd crash. So if you were to look at device 1 on machine 1 and then device 2 on machine 2, their IP addresses would look like they could communicate, but they weren't plugged into one another. So it's networking, you really, there's no magic answer. I'm sorry. Did I make it worse, or did I answer your question, Vincent? Thank you. Gateways. So this is that last piece that you've probably seen in your computer or set up when you configure your router, your gateway. So the gateway is used to connect two or more devices from different networks. So this is getting into routing. That's right. So for example, device A is an Ethernet cable connecting to device B, and then device A1 and then A2. Devices A1 and A2 are on one network, and device B has a different network setting than device A1 and A2. These devices can't communicate unless you add in gateway routers. So the gateway connects two or more devices from different networks. So the device A1 and A2 connect to gateway A. Gateway A then points to gateway B, and device B points to gateway B, and then the routers will handle the inter-network traffic. And this is the internet. Very low level. So devices A1 and A2 and gateway A are on one network, and devices B and gateway B are on a different network. And then the gateway A and gateway B are programmed to talk to one another, which links the two networks. So this could be factory floor communicating with corporate. This could be Toronto office communicating with Vancouver office. Routing can be very short distances, very long distances, but they will take two different networks. So device A could have an IP address of 10.10.10.10, and device B could have the same IP address, but the routing would handle that, so that even though these two had the same addresses and they were somewhat connected to one another, the gateways would handle and allow them to exist on the network at the same time by routing. So all the devices can communicate. Does that make sense? Like this is very high level routing. If it seems like I'm flying through this, you really need to understand these basics, and we'll get to why they're very important for getting your PLCs going. So what is a MAC address and why are they used? So a MAC is an acronym for machine address code. So all devices have a unique MAC address. So these are typically assigned by the manufacturer. MAC addresses help differentiate devices on a network. And then servers will assign IP addresses to computers, and the server will use a MAC ID to tell one computer apart from another computer before IP addresses have been assigned. So the MAC address is typically hard coded onto network cards. So if you were to flip over your computer, even open up your phone, flip over your router, you'll likely see a number broken up like this. This is what a MAC address looks like. So they're typically stored in read-only memory and can't be modified after the manufacturer sets them. There are some examples of devices that you can change MAC addresses for, Virtual machines is one of them. So like IP addresses, MAC addresses have to be unique on a network. So if you were to take a VM off of one computer and transfer it over to your colleague, and then he would boot that VM up, if he didn't, even if he changed his IP address or his IP address were dynamically assigned to him, if he didn't use the virtual software to like re-roll a new MAC address, the two competing MAC addresses could confuse the switches and neither of you may get traffic. So you need to know what the MAC address is, but how the MAC address is used in the background of data, like packet transport in networks, is beyond what we need to talk about or what you need to know. But before you have an IP address, so when you plug your computer into your network or you plug a PLC into a network, if it doesn't have an IP address but is capable of receiving a dynamic address, the switch or the server which will assign dynamic addresses will see the MAC address and will assign an IP address to a specific MAC address. So they're used hand in hand, but when you're going online with PLCs, you're typically not having to look up the MAC address. And the MAC address on some PLCs is only visible if you remove it from a card. So you'd have to physically remove it from a rack, which is just not really an option in a running system. Any questions? An interesting tip here with MAC addresses for even your home network is if you're in your home router and you pull up, normally you can pull up a diagnostic list of the different devices that are connected to your network. Your MAC address will be in that table. You can look at the MAC address if you copy and paste it into the internet, and typically it'll be able to tell you roughly what it is. So if it's an iPhone, you can paste it in there and the internet will be able to tell you that it's an Apple product. Because a lot of these are assigned by the manufacturer, normally a manufacturer will have the first couple of digits will be manufacturer specific. So if you don't recognize a device on your network, you can look it up via MAC address to see what make it is. Or you could try to, if you see the IP address, you could try to log into that IP address like you would log in your router and see if it has an interface. You can do that with PLCs too, which I'll show you later. Okay. Ping. Who's used ping before? This is easily the most useful command for network troubleshooting. Anybody? Somebody has to have used ping. Yes, of course. Thank you. Yeah. So ping, I didn't know this until I reviewed these notes, is an acronym. It stands for Packet Internet Gopher. I looked it up. It's adorable. This is used to debug networking issues between devices. So it is literally the first step in diagnosing whether there's communications between two devices, and a super useful tool that if you don't know where a free IP address may be on a network, if you can get onto a machine that is already on the network and ping and get no response back from a specific address, there's a good chance that you can then set the IP address of your machine to that address and then be able to access the PLCs with your programming software. Ping can be used to test if your PC has networking enabled. It can test if your PC can communicate to a specific device, test for IP address conflicts. So the ping command. So everybody should have this. I even believe the Mac users have ping. So for Windows, you will open up command prompt by opening the Windows, hitting the Windows button, typing in CMD, and then launching that application, and it will pull up something that looks like this. Type that into the line PING space 8.8.8.8. And this is Google's DNS server. You should then receive back replies. So how many bytes you received back, the time it took, and the TTL. I can't remember what TTL stands for off the top of my head. So you should be able to reach 8.8.8.8 because it's Google. And if it's down there, losing a lot of money every minute. And try this. It's super useful. So IP config command. So this, like when I started, I was talking about very useful tools. These are useful even outside of PLC programming. I'm sorry, I hit my microphone. If anybody has headphones on, I'm sorry about your ears. So you can ping devices in your home network to try to find your printer, try to find your phone, whatever on the network. You can set your phones. You can even go in, and once you understand the difference between dynamic and static addresses, you can even set some of your devices that you want to be at the same address all the time. So I always set my home printer to a static IP address. So it's not, so I'm not trying to find it, and it doesn't move around in my configuration all the time because it's really frustrating when it does. So ping is something that you can use on any network. Any Windows computer has that ability. IP config command. So this is used to identify the specific computer's IP address. So it's useful for finding out whether your computer is on the right network. Capitals don't matter. So this is common syntax for the command prompt, but IT config space / question mark. That'll be the help menu. IP config / all. This will list all of the adapters for your computer. This will include Wi-Fi, physical adapters, and then any adapters that might be communicating with VMs. IP config release. So this will release, we were talking about leases. So if you have a dynamic leased address, you can force release it. So you can force release all of them, or you can force release specific ones. And then renew, you can request a new IP address from a machine. That might be useful. Let's say you rebooted your router and your computer thinks its lease is still good for another week when it's not. You can release it and then request a new one from the rebooted router. So if you open up the help menu, these are all the different options that you can see. So again, release will release the specific adapters. Release 6 is for releasing the IPv4 and IPv6. You can renew the IPv6. You can flush your DNS resolve cache. You don't really need to know much about DNS. Yeah, there's lots of, you can see the commands there. You can play with them. You're not really gonna damage anything if you change any of those settings. So /all will list all the different adapters. So the example here is the wireless LAN adapter, nothing on wireless LAN adapter 4. There's nothing here. The wireless LAN adapter Wi-Fi. Whoops. Sorry. I clicked. This one's connected. So Hytron Hub Home. So it's called Killer Wireless. That is the physical MAC address or MAC of the network card, the Wi-Fi card. DHCP, so that is dynamic host something protocol. It's coming back. Auto configure enabled. Different IPv6 leases, IPv4 leases below that. Pretty, I mean, not that it's pretty straightforward, but it lists everything. It even lists your Bluetooth adapters if you had anything. Even Bluetooth devices have MAC addresses. So IP release, this is it confirming it's released. Renew, it'll pull new addresses. So comparing networks. So can CPU A and CPU B see each other on this network? Can they ping each other? So by looking at 10.64.123.25 and 10.64.123.130, their subnet masks match and their gateways match. Can they ping one another? Does anybody have a guess? Yes. Yes, they can. So breaking down the subnet, yes. Yes. We're happy. What did it do? Oh, so they've changed. So we've got different subnet masks. Can these two see each other? Somebody, I'm not going to make you break out the converter. No, these two cannot. The masks prevent it. So these ones we don't care about, but this one doesn't line up. They're too far apart. So the bigger the number for the subnet, the smaller the network segment. So if this is 128, I forget how many segments it's at, but you would normally need, like, these are over 100 apart. I think it would have to be a subnet mask of like 28 to reach that. The smaller the mask, I forget the math off the top of my head, but the smaller this number, the more devices in each segment of the network. That's how I remember it. And if they're not side by side, I always have to do that mask. So conclusion. Devices on the internet use IP addresses to identify one another. This is universal. All computers use IP addresses to identify one another. Subnet masks help break up local networks into groups, so only certain IP addresses can talk to one another. And devices on their own local area network use gateways to talk to one another. Devices are all on their and use gate. Okay, sorry, that's worded wrong. I have to fix that. So these devices, A1 and A2, are on their local network, and are connected to gateway A. Device B is on a separate network connected to gateway B, and they use the gateways to talk to one another. The ping command is the first used tool for diagnosing connection issues between you and your PLC. If you can't ping it, you cannot get online with it. The IP config command is good for diagnosing whether your device has network settings, that you have network settings that you expect to have. So, and I'll show you how you can change some of those. Okay, that's the end of the presentation. I forgot to watch that. You guys can take a break. My VM's probably going to take 5 minutes to load. Excuse me. Am I showing the right screen? You guys are seeing the, man, all my chat's closed again. Yes, thank you. So for Windows 10, and it's the same for Windows 7, you can launch the Windows menu, CMD, command prompt, and we'll launch the same window. So we wanted to ping. So that device was 192.168.1.80. We can see we can ping it. So that means that at least this computer is on the network and can see that device. IP config without anything else. We'll show you the active network adapters that you have. So I have an Ethernet adapter, an Entron hub. It's telling me my IPv4, IPv6, my mask, default gateway as a IPv6, and a default gateway as an IPv4. Then I have VMware hosts. So I've got multiple VMs that run on this machine. I have 2 different hosts to VM networks. All just shows all of the network adapters and a little more information about each IP all. So my desktop name, this will talk about the actual card. Realtek, talk about your lease times. This is really useful. Again, if you were to show up to a machine, a computer in the field, or even sometimes quick panels or touch screens, and find out what the IP address is of the machine, that'll really help you. So you could do things like launch that CMD IP config, write down the IP address of this machine, and you can see the gateway, the preferred gateway. Well, and then you could ping around. So if you wanted to know if there's something else available, so you could ping 192.168.1.106 while there's something at 1.106 on my particular network. You would also be able to see under ipconfig/all, you can see DHCP is enabled. This is bothering me. DHCP, dynamic host configuration protocol. I Googled it. I'm sorry, I don't know everything. So if you connect to a computer, you open up IP config and see that DHCP is enabled. well, then there's a good chance that if you can plug into the same switch, or you can plug into something that plug into the device that computer's plugged into, the DHCP server, well, whether that's a domain controller or a switch or a router, may assign you, oh, Olu's back. So if you can open up ipconfig and see DHCP is enabled, you might get lucky and be able to plug your machine in. Make sure your machine has DHCP enabled. How do you check that? So for Windows 10, open up the Windows menu and go network. That's going to open up this interface, Ethernet, change adapter options, and then you're going to find a number of adapters. So this is the one that I have plugged in. You can open up properties and go through here, and you can see, okay, well, this is set to obtain an IP address automatically. If you were on a network that you were not getting automatic addresses from, so you weren't getting any sort of dynamic update, you would just click use the following and you would plug in the address that you wanted. Now, if you don't know, you're running a risk of conflicting. So if I were to plug in, I'm not going to do that, because that will disconnect me from the internet and thus stop me from teaching. I'm glad I caught myself. If I were to change my IP address to something that was on the network, depending on how sophisticated your network card is, it might be able to tell you you're about to conflict with another device. If you do conflict with the wrong device, you can stop the whole system from running. So if you accidentally made your computer the main PLC or the main drive or the safety controller or the server, the historian server, the data uplink server, the main router, something that everything needs to talk to, all of the communications, the switches could then start trying to forward your machine data, and then everything could fault if their comms die. I showed up at a manufacturing plant. They made Nesquik powder, and they were saying that their line had been down for days and it kept randomly shutting off and nobody understood why. And we found out that the week before, the company that owned that company got bought by another company, and they had sent out their like super corporate IT people and dropped a data dropped a server on site for some reason. We're not quite sure what it was, but that server they dropped on site had a DHCP server enabled, and it was issuing DHCP addresses, and it assigned DHCP addresses in a range of addresses that were already being used in the automation system. So as soon as that machine turned on, assigned an address to a couple of the computers on the network that were set up to receive them, they conflicted with a handful of their VFDs, and their whole system came to a halt. They actually, when it came to a halt the first time, they were in the middle of a pasteurization process. And because of the failure, they lost their whole pasteurization certificate. And that cost, I think it was $57,000 it costs in materials for the batches that they were pasteurizing before they manufactured. So it may seem pretty innocuous, and the IT people had no idea what they were doing, but it shut the system down for days for us to find it, because this piece of equipment was hidden in the back of a room. So if you don't know the network, it's really dangerous to just plug things into it. If that's your only take home today, it's a good one. So this VM is a Windows 7, very similar interface for command prompt. So config all, it's going to look the same. I'm assuming Windows 11 is going to look the same. I haven't played with it at all. So this one's got the same gateway, but because it's a virtual machine, it has its own IP address assigned to it. Sometimes PLC networks don't work well with NAT. You've probably seen that if you use like PlayStations or Xboxes, they'll use a NAT configuration, which is a network access translation for your main router to share an IP address. Typically with VMs, you want to give your VM its own unique address on your network, especially if you're using VMs for PLC programming. I've had lots of issues. So again, you can open up IP config in your VM, do the same thing. You can get in here, type in network. What did I hit? Okay on control panel, network, adapter settings. If you have any VPNs pre-configured, they'll show up in here as well. My local network. Again, we're set to automatically obtain DHCP, but I could change the address of my VM in here, just plug it in the subnet mask, the gateway, DNS servers. Any questions on how to change your IP, find what your IP is? I know somebody said they had a Mac. I think it's similar, like the way you find it is similar. I don't know where to dig around for that stuff. I'm sorry. So with IP addresses, once you know them, so I'll launch links here. There's a few things we can do while that loads. Here's another really neat ping. Yeah. So if you ping a website, you can ping just google.ca and it's going to return back. This is actually its IPv6 address. But you know how I was saying the internet is a whole bunch of routers and gateways redirecting to one another? At least I think I said that. This is trace RT google.ca. So this is called a trace route. So what it is actually doing is it's headed to the google.ca machine. It'll take longer than a normal ping, but it's going to tell me it timed out. Interesting. So it'll normally jump from each one of the router points between myself and the endpoint. Interesting that it timed out there. See if there's another. Let's go trace route. So it'll jump from each one of the devices to the next. So the CODA 4582, that's my gateway. And then you can see from my gateway, it jumps to my router. The router is jumping through Rogers now. And it'll tell you all the different devices all across the internet. So you can use trace routes internally as well. So if you're online with a controller and you think there's something funny happening with how it's communicating, you keep getting dropped packets, you can run a trace route to it and see how many routers or how many odd devices you might be going to. And if you run that a couple of times, I've found more than once that if I run a trace route within 5 or 10 minutes, if I don't get the same response back, it means that somebody's cross-connected the network somewhere and there's multiple communication paths, which is not good for automation networks. So Trace RT is a really, really good troubleshooting tool if you're already connected to a network. I don't think it's anywhere in the reading materials. That's just an extra while I was waiting for my links to load. So with links for Alan Bradley anyway, and there's a few other, if you're dealing with GEI fix, there's a couple of communication drivers. Again, we've covered that Rockwell RS links is how your computer talks to the PLCs. Another way to troubleshoot your connections is to see, well, can I even see these in links? If this was working before and is no longer working, maybe there's an issue. If you come across a computer and you might not have administrative access to run something for some reason, see if it has RS links installed. So that'll either be in the start menu or it could already be running. It is, isn't it showing up? Maybe I have to minimize that. It's not showing up for some reason, but its logo looks like that. Two computers with a chain between them. A lot of the time somebody will have configured an IP address listing. That is a gold mine if you can find one that's already got a bunch of stuff configured inside of it. It really help you at least get started. So let's say you were to find this, or you find that Logix processor, like I showed you on my stand, and we'll use this browser. And 192.1.80. So a lot of new technology will have its own web browser. So just like you can log into your, sorry, I hit the mic again. Just like you can log into your router, if you've got a network access storage device, your printer, sometimes you can log into the web interface, change some settings. You can log into the interface for control logics and even slicks, I believe. I think these ones have the latest firmware on them. Yeah. So once you're on the network, you can log into them, see the controller information they're running, how long they've been on, firmware. You can't do a whole lot with the web interface with the slicks. Actually, I don't even think you can do, so you can see here static, Ethernet, the MAC address, diagnostics information. Most of this stuff's not really important. Is there anything that one of these should tell us? There. How many devices that it's communicating with. If you're ever having comms issues with a slick and you can access the web interface, if this number is over 30, you might have maxed out the particular network card. It can't talk to too many devices. But again, web interfaces for devices, really good troubleshooting tool. Even if it's just to let you know if it's up, if it's doing something. There's a big difference from a device being powered on and plugged into a switch and powered on and communicating with something. So just because it's plugged in and there might be a light flashing on the switch, that doesn't mean it's doing anything. It doesn't mean it's configured properly. Again, getting into the browser interface for the control logics, you can see it's a lot of the similar information. You can't configure anything, but you could pull some statistics out of it, some diagnostics information. You can browse the rack to see all the different cards that are in there. You'll notice I had 2 network cards and one of them is just not even showing up. It's broken. Yeah. Has anybody used these? Did you know they existed? Have you ever tried to log into the interface of another device just to see if there were anything to play with? It's fun to see what's unlocked. This is also the other side of this coin. Is a lot of these interfaces have 0 security. So if your network is facing the internet and somebody were to be able to see these, it's going to respond back. So yeah, they're really powerful, but it also can be a beacon for people who are sniffing your network for specific types of devices, especially some of these older slicks, older touch screens. Up until very recently, those touchscreens all ran on a watered down version of Windows XP, which is a nightmare network security wise. So yeah. So if you have here, if you've got a slick, I'll show you guys how to configure that. Where are they? So let's say you've got a slick processor, you've got the code, but you don't have anything else, and you need to go online with it. Where you'll go here is under channel configuration, and this is for slick 505s, as well as any of the micrologics with Ethernet. Open up channel configuration and then go to channel 1. This is what is currently configured in this is what's configured in this offline version of the code. So what's actually online might not be this exactly, but you could set your computer to this network if you know you're not going to conflict with anything, and try to find this controller at .91 to get online with it to verify if it's there. But this is at least a starting point that you can see. If you had a new controller, a lot of them by default will actually come like this. Boot P enabled. Boot P is an industrial version of DHCP. So it's a dynamic protocol for setting network addresses. Do I have that here? So not all the time, but I have found this once in a while where they will use this boot P commissioning tool server, and it will that should. So I'm just gonna see if this will update. I haven't had a ton of luck running this tool through a VM, but what you'll see here is if there's a controller and you don't know what's on it, you can always connect to the network and see if they've left it as a boot P device. If you don't know its IP address, if they've left it as a boot P device, its MAC address will show up here, and then you'll be able to assign it. This was never going to show up because the actual device on the network's not enabled. So if it were looking for a boot P address or a DHCP address, there's kind of a conversation that's happening on the network. To dumb it down a little, the device will not have an IP address, but it will say the switch will see its MAC address and then ask it, are you boot P enabled? Are you DHCP enabled? If it says yes, it will assign it an address. And then the router or whatever the server is will then create a table of what address is assigned to what MAC address, and then it will communicate with the switch or the domain controller, and then all of the traffic on the network will be routed to those addresses. So I've seen, I don't love it, but I've seen entire networks set up there. There's a DHCP device that this found that doesn't have an IP address, but it has a MAC address. And like I promised earlier, I'm going to Google that. Did I promise it? Hardy, is that a question or is that? No, dynamic host control protocol. Data highway is a proprietary thing for Rockwell. So I tried to look up that MAC address. Looks like it's a watch or something. I don't know what it is, but sometimes it might be an Apple device. Whatever. Won't go down that rabbit hole too far. No. No. So for slicks, for PLC 505s and MicroLogics, an IP address change absolutely requires a download. So if you're going to change it, you need to set it. You have to download that with the program. The whole system has to go offline. It's kind of a pain in the butt, but that's just the way that works. Any questions with the slicks while I'm still here? Oh, okay. So unfortunately, let's launch. With Logix 5000 or Studio 5000, depending on, this is firmware revision 19. You can see under system protocols, you don't have the same information up here offline or online. You do have Ethernet configuration. So down here, this particular controller is a L61 and there's an Ethernet slot, well, I can open up the offline properties of it. Oh, and somebody set them. This right here, though, is informational only. This does not actually, especially with your offline code, this does not equate to the actual address of the card. If you were online, port information would show up, but offline, you don't really know what's going on. See here, this one is blank. So we don't know what's going on. RS networks would be for communicating typically with drives, VFDs, or you can communicate with some other automation equipment over Ethernet. Data highway that Hardik put in the chat is one of Alan Bradley's. Do I have a driver here? No. So DH485, so data highway 485, RS232, but DH485 is a data highway plus. It's a proprietary serial connection. So yeah. So if you've got a Logix 5000 program, you don't necessarily know what the IP address is. Doesn't matter how well you dig through the code, unless it's documented somewhere in a note. You've got to almost have to find it on the network. So if you found it, obviously you know what it is. You can go to module configuration. Here, this is where you would change the configuration of the module. So if I wanted to change the IP address of my Logix 5000 controller I have here, I would change it. And this is kind of important because it might be very frustrating. If you open it up, you can see that the first instance of the network adapter, the card that I see here, is on the card itself, but it's in slot 1. If I were to open up, I can see the controller and I can see slot 1, but I can't do anything in the slot. You can only change settings of the network adapter of the top instance of it. So I could change to dynamic. I could change an IP address. I could set primary or secondary servers, make those changes, then hit yes to confirm it. But you do, for that to take, you do need to, do you need the cycle power? Yeah, I believe you need the cycle power on these still, for everything to finalize. But you don't need to download. But if the card is in the rack that has the PLC, then you might as well have downloaded because you have to cycle power. I forget what might not work if you don't cycle power, but it's good practice. What you'll typically see is actually the address will show the new one. You know what? Let's change this. Let's see. Let's change it to 89. Yes. So it doesn't exist at 80. Looks like you don't need to cycle power. Neat. So again, your driver here is a home is a AB Ethernet driver. If you know you have control logics or compact logics and you don't know IP addresses and you have links and you're on the network, one of the things you can do is go to Ethernet IP driver. So this is Ethernet IP is actually industrial protocol. It's another one of Alan Bradley's coined terms. But this protocol actively scans. So you notice how I didn't enter anything in? It automatically found all of the controllers which have industrial protocol enabled in their firmware. So it was able to find both of my slicks because they have the latest version. Well, they have version 10 or higher of their firmware. And it was able to find my Logix 5000 processor. So if you approach a network that you know is Logix 5000 and you don't know IP addresses, a good troubleshooting tool to try to find those is to use the industrial protocol driver. So you just go under communications, configure driver, Ethernet IP, add a new one, and then just make sure you point it at your active network connection, and it should be able to find any IP devices, industrial protocol, not internet protocol devices from Alan Bradley. Sorry, I'm just reviewing some of my notes of the things that I wanted to touch on. That's about it. Are there any questions? No.
Ryan.
Shoot.
Yeah, for the old slicks for the micrologics, if you don't have the address and you have to use like a DH486 or a PMK cable, like how do you know what cable to use? Like we get some older ones at work and we have a hard time going online with them because we don't know what kind of cable they take.
All right, so if it's a slick 503, it'll be a DF1 cable. 503 or 504, it'll be DF1, which is like that 9-pin serial cable. If it's a Micrologix, it's this. There's a funny part number for it, and I got one of the silly things. Ugh. I'm gonna grab my cables to show you what I use. So Allen Bradley is notorious for selling you a 50-cent cable for $700. So they're good at that. They all are. So I have a programming cable for a Schneider drive that I think costs $497. And once I had it in my hand, I was able to pin it out and make my own for $8. I mean, it costs $8 in material, but I think it cost my boss like half a day's work. So was that $500? I don't think so. But anyways, if you have I'm going to turn my camera on somehow. Start video. Stop share. So if you're going online with a Slick and you have a serial port on your machine, this is all I use. This is a modem cable with a null modem adapter on it. Can you see that? So this is just like a normal with null modem. It's called a gender bender that goes from male to female. That gets me online with my Allen Bradley Slick 505s, 504s, 503s, and even the 1769 L33s, L35Es, anything with that 9-pin serial port. If you don't have a serial port on your computer, you need one of these. So this is a USB to serial adapter. Try to get one. This may sound silly. Try to get one with a light on it. And you need to make sure that when you plug it into your computer, that light turns on. If that light doesn't turn on, you don't have a chance, because it's not going to be powerful enough to power the circuit to get your data, like to establish the communication with the controller. So some of these cables are way better than others, and it's kind of a crapshoot. But the problem with these is you need to muck around inside your configuration of your computer to switch your port, and I'll show you that in a second. If you have a MicroLogix, you need one of these cables, and this one is a bloody fortune, but this is that funky end. You see that? So this is a PS2 end with that little crimp on it, and this is the only serial cable that will work on a MicroLogix. It also works on net ENI modules, if you've ever seen those, and the other end is just your normal serial cable. So these serial cables are invaluable, and if you don't have a serial port, one of those. Does that help? And I'm gonna type into the chat. I'll type in the part number if I can find it on this. Yeah, MicroLogix COM cable. Yeah, 1761 CBL PM02 serial C. So there's a couple of things that you need to do for that. So you have to go into Device Manager. Let's see how this works. There. So that's my USB to serial converter. So the first thing you need to do is go to device manager.
Can we see your screen, Ryan?
Yeah, you sure can. Sorry. I got too excited. So I just plugged in my serial controller. So if you're in a VM, just make sure it gets into your VM, then go into device manager. And then you're gonna want to find ports. So your computer will arbitrarily assign COM ports to these things when you plug them in. So this time I plug this in, it's on COM port 9. So you can open this up and take a look at all your baud rate settings for the driver, and you can change the port if you really want to, but it doesn't really matter. The only thing is that you can't change it to COM 0 or COM 0 or COM 1. It doesn't like it because those are automatically assigned elsewhere. So you need to stay away from them, which is a problem in Lynx because when you add in a RS-232 DF1 driver, it wants the COM port. So you need to make sure that you match the COM port that your computer arbitrarily assigns it. And then you need to find your device. So your Slick Micrologics or panel view is going to be that guy. And then you should be able to click, like hit auto configure and see something. If I do this, it's going to fail because I'm not connected to anything, but it's going to run through all the different configurations. And this one's going to tell me that I'm no good just because my cable's not 20 feet long to reach my controller over there. Yeah, that should get you online with it. Does that help? The big one that took me a while to keep remembering was this guy. And make sure that that and that are the same.
Right, and that helps a lot.
Yeah, no problem. Good question, and I never would have thought of it. Yeah, you'll find serial connections. The longer you deal with controllers, the more weird stuff you'll find that they can do. Like you can, I don't know if you've seen this at all, but under channel 0, you can change channel 0 to be a bunch of different things. So you can completely shut it down and then channel 0 does nothing. You can change it to DH45, which is data highway, which means you would need a special data highway, device to talk to it. But if it's on default DF1 full duplex, you should be able to use the auto negotiate or even come into channel 0 and take a look at some of these settings to see if your auto negotiate doesn't work. Like not auto negotiate, the auto configure if it doesn't work. You can go into the controller and make some guesses. And then that's the same for these guys. So the controller I have here is a serial controller. So you can also set it to different protocols on that DF1 port. So it can be radio transmit, DF1 master, DF1 slave. You know how we were talking about client versus server? That's kind of a master versus slave thing. Not really. Forget I said that because it doesn't really make sense. But I haven't seen very many DF1 installs. Though you can get some slicks that will what am I trying to say? If you find a touchscreen attached to a slick processor with a serial cable and nothing else, that means that that touchscreen has been downloaded through the processor over Ethernet. So it's good to know how, like, that is possible, that you can actually access how do you do that again? There is a way, I just can't remember where it's configured right now, that you can download to a DF1 device through the serial port of a SLIC over its Ethernet port. And it's called slaving, I believe. And I every once in a while, I probably ran into it like half a dozen times in 10 years. Every single time it was a nightmare to figure out, to try to get the touchscreen, because whenever you need to do work on a PLC that's attached to a touchscreen like that, you need to make sure you can communicate with the touchscreen before, during, and after. And if you wipe it for some reason, the first thing you need to do is try to pull the application off of it so you have your starting point. So it's always a bunch of Googling. I'm rambling. Any other questions? Any other weird things you want me to go over? Because I think yeah, that's all I've got to really teach in my lecture. There's a quiz for this week. There's no there's no assignment. Next week we're gonna go over electrical drawing stuff, and we're gonna start I think it's a group assignment, group discussion. Yeah, but this week I think that's all the material I've got for you guys. If you guys want to ask me questions, if you want to see something, stick around. I'm gonna try to mark your assignments that you've put in the next hour. Yeah, that's it. So fire questions away, or I will see you next week and or tomorrow. Bye, Scott. Good night, Robert. Oh, here's one. It's a free one for you. If you use a USB to serial port, like plug, your computer will assign it a different COM port for every USB plug on your computer. So, and it will duplicate the driver. So if you want to try to keep a clean registry, try to put your USB devices in the same ports all the time. That way you don't end up constantly having to fight with finding what COM port your stupid controller's on. Oh, I'm still sharing. All right.